Let's look at an example of rewriting functions into piecewise. Rewrite the following function as a piecewise function. So this function is an absolute value function. What does that mean? Absolute value means it will make any numbers positive. So let's think of this graphically. I'm going to graph the absolute value of x plus 5. So I'm going to sketch a graph of, well, actually, let's think of sketching the graph of y equals x plus 5. So what if it just looked like this and not the absolute value part? We know this is a y-intercept, 1, 2, 3, 4, 5. We know the slope is 1. So we get some more points going this way. And there's our line. Now, because the absolute value makes everything positive, the part that is in the negative region down here, all of these negative y values, see here, these are positive y values, 1, 2, 3, 4, 5. Down here, these are negative 1, negative 2, negative 3. These are all the negative parts down here. So this part of the graph right here is in the negative region. If we're taking the absolute value of x plus 5, we're going to get rid of the part that is negative and make it positive. So if it was negative 1, it becomes positive 1. Negative 2 becomes positive 2. Negative 3 becomes positive 3. So there's the new version instead of like this. Hence why we get the V-shaped graph for absolute value. So rewriting it into piecewise means we're going to rewrite each piece as its own function. So together, it's going to look like this. F of x equals. Now the red part comes first. So we're going to write the red part first. Now notice that that part had to be flipped over. So whereas it was the graph of y equals x plus 5, we had to switch it from negatives to a positive. So how do we do that? We take the opposite of it. What does the opposite mean? The negative. The negative of x plus 5. And where does that happen? Well, everywhere to the left of where this crossover point is, this x-intercept. How do I know where this x-intercept is? Well, by graphing it, I see it as negative 1, negative 2, negative 3, negative 4, and negative 5. It's at negative 5. However, if I don't want to graph it, which I shouldn't have to do, I'm going to look at that part of the function in the absolute value. I'm going to set it equal to 0. That's how I find the zeros of the function. And then I'm going to say, solving, that x equals negative 5. So that's where the crossover point is, or the x-intercept. So the red part that we had to switch over is everywhere to the left of negative 5. That's where x is less than negative 5. The blue part, the part that we didn't have to switch over, is what it was from the function, regular x plus 5. And that's for everywhere to the right of negative 5, so for x greater than negative 5. Now we do have to include this point. It doesn't really matter if it goes with the red graph or the blue graph, the part coming down or the part coming up. We just have to include it somewhere. So we put it there.